this edition of the Embedded Insiders, Brandon and Rich discuss the semantics of AI and intelligent technology, and what classifies as a smart system these days. Have marketing engines turned these into overused terms? Are they even being used correctly? Later, the Insiders take a deeper dive into the practicalities of Edge AI with Bill Pearson, Vice President of the Internet of Things Group at Intel. Together, they investigate market challenges such as hurdles to realizing ROI on their initial AI deployments and the hardware-software technology gaps preventing developers from launching commercial-grade solutions faster. Finally, Alex Harrowell, a senior analyst at Enterprise AI, speaks with Perry in this week's Tech Market Madness about a new report from Omdia Research titled Artificial Intelligence for Edge Devices Report.
Welcome to another edition of the Embedded Insiders. I'm Brandon Lewis, Editor-in-Chief of Embedded Computing Design, and I'm here with Rich Nass, the cranky Rich Nass today, right?
A little bit. Well, I ran into an issue, and I don't know if I told you this. My house, which is fairly new, I've tried to make it completely automated, and having a smart house is super cool until you lose your internet. All of a sudden, I don't know how to turn the lights on. I don't know how to open the doors. I don't know how to turn on music. I mean, it was a little scary. It was like 36 hours. I couldn't do anything in the house.
Your robot housewife wouldn't move around anymore?
Well, even the friggin' vacuum doesn't work.
Oh, man. You know, that's why you got to go off-grid, completely off-grid, and move into the mountains. I thought you were a handy guy. I thought you would be totally self-sufficient.
You would think, but you know, something so simple as figuring out how to turn the light on was a lot harder than I thought it was going to be. Yeah. But anyway, I have another issue that I wanted to talk to you about. Maybe 10 years, or I guess it's less than 10 years, maybe 5 years ago, when IoT was super in vogue, all of a sudden everybody had these products that were IoT products.
Right.
And it was the same products they had before, the same capacitors and whatever it was, but it could be used in IoT systems. So now it's an IoT product. And I let it slide. I didn't really say anything about it. Now I'm seeing we have COVID-19 products. Well, this capacitor can be used in a ventilator and it's saving lives. So it's a COVID-19 product. No, it's not. It's a capacitor. And it annoys me that people are using the pandemic to their advantage to say that this product is actually different than it really is.
Well, I am going to take this in the vein of electronics marketing. That's because everybody's looking for whatever's going to drive the most traffic. I mean, it's if it's ambulance chasing or not, you know, like, hey, what's going to get people to click on our X? Well, put COVID-19 in there, right? I mean, it's unfortunate, but it's true. And honestly, I don't think it serves anybody very well to do things that way. If you're really looking for a COVID-19 capacitor, you probably already have made the connections you need to, but you know.
And we've had people come on who had things that were really related, you know, and I'm not saying anybody should be giving away the product, but we have had people come on who said that they're donating XYZ if they know it's going to research for COVID-19, or we've had products that were specifically designed to diagnose COVID-19. But just to say your widget, because it ends up in a box that might be used in something, is a COVID-19 product, that's just not fair.
Well, it's a little sleazy, but hey, you got to pay the bills.
Okay. All right. Thank you for allowing me to vent. Sure.
Of course, anytime. I know it's been a tough day. You can't even talk to your robot housewife. Like it's moving right along. Speaking of things that everything is becoming an X type of product, is now, have you noticed that everything is an AI product?
No.
Well, I've noticed a lot of things that are AI products or intelligent somethings. You know, this this memory is really good for deep learning workloads, or, maybe this capacitor is optimized for delivering the voltage to your intelligent edge system. Like, it just is. It's the marketing hype cycle. You look at the Gartner hype cycle curve, and it's true. Everybody gets on board this high-speed train of whatever the application du jour is, and then we ride it until people say, I'm sick of hearing that. Like, remember when we would hear, industry analysts project that IoT systems will account for XX% of the blank market by some year, 5 years in the future. And today, I think we're there with AI. And one of the things that drives me nuts about AI is that it's mostly focused on computer vision. I can't get over the fact that there are so many different applications of artificial intelligence, and everybody appears to just be stuck on computer vision.
I don't know. I'm sorry to be a dissenter again, but I'm not seeing it as much as you are. Things that are there's a lot of different definitions of the edge. I like the definition where it's really out by the sensors, and a lot of that is not about the vision. It's about the decision making, and it doesn't really matter what the input source is, whether it's temperature or it's watching people walk by or whatever it is. It doesn't necessarily need to be vision. It's the decision part of the process.
No, but what I mean is that the algorithms that are being created, there's so much emphasis right now around the actual system components. You can't run a vision algorithm against a microphone input. It's designed to look for specific things within an image. And I think that that's a really big disservice, because to your point, like, if you look out at the far edge, there's so many different things to be measured and analyzed. And honestly, there's so many things to be measured and analyzed that could probably be measured and analyzed on technology that already exists or is much lower cost than what's being pushed out into the market right now. I mean, if you think about it like a threshold value, some threshold is breached, do X thing. It doesn't have to be intelligence in the form of convolutional neural networks that are 50 layers deep, and you run it through one filter and then it goes to another filter depending on what's happening in the image. It's just I think that the way that the technology is being driven, the way that the development of the technology is being pushed, does a really big disservice to artificial intelligence in general, and more specifically to a lot of the different use cases that could super benefit from a little bit more enhancement of the paradigm.
Well, what I'll say to that, with all this data that we have coming in, it's a good thing we have IoT memory.
Right.
Now, the insiders are joined by Bill Pearson, Vice President of the Internet of Things Group at Intel.
All right, Bill. So AI at the edge is the big topic du jour today. 10 years ago it was IoT. Before that it was M2M, and now everybody's on to AI. We hear a lot today about computer vision, but is that really the only place where AI is taking off? Are there other applications at the edge that are taking advantage of artificial intelligence?
Wherever you've got data, in the future, you're going to have AI, and you're going to want to process that data, do something interesting with it. And yeah, most applications today, we see computer vision as being really relevant. There's a lot of camera data and things you can use for inspection of defects in manufacturing lines and that sort of thing. But as we get more data and as developers get more crafty, I think you'll see things like audio, things like vibration detection. Again, things where you've got a need to do, autonomous robots, for example, and then looking at the data sets that are available to make those things work.
Okay, so let's talk about the actual benefit. When I'm just going to liken this back to IoT, at first, everybody was like, yes, IoT can do all of these things for you. You can save all this money. You can do predictive maintenance and your machines will never go down. You can have 10% fewer employees, all that stuff. And then it obviously took a while to happen. And then one of the reasons for that was that people started putting all of these IoT sensors everywhere and just collecting data. And then it was like, wow, now we have a ton of data. Like, what do we even do with all of this? what's the ROI of Edge AI, and how do you sort of circumvent that weird data overload that we experienced with IoT?
Yeah, I view these things as more of a continuum, I guess I would say. When you think about IoT and the process of collecting data, there are continued business benefits for customers doing that. But as you pointed out, what quickly happens is you realize you need more. So it's not enough to just collect a bunch of data. You need to figure out how to analyze and process that data to make sense of it. And we see customers who are able to get real ROIs today from this. I'm thinking of a company, Rossmart, that we work with, and using Edge AI, what they've done with their solution is really drive improved accuracy, but at a reduced cost. So they're able to also pull out recurring annual cost out of their production line. That's true in we see it in defect detection, in textile manufacturing, in real-time inventory management. So lots of different domains where developers are able to come up with interesting ways of making sense of that data and then doing something useful for it that helps reduce costs. One example I'll share here. I was talking to a developer recently, and what they were trying to figure out a relatively simple problem. They didn't even know what the loss was from their retail environment. There was some, they had a sense that people were taking vodka and scanning potatoes was the scenario, right?
Right.
And so they're looking for a really simple AI solution to be able to just detect, is this vodka or potatoes? And they have a loss, they have an ROI, but they can't quantify it. And so what we can do with Edge AI is help them understand the scope of the problem, help them with solutions that are good enough to be able to go and then take action on that problem, right? Is it small enough that they don't need to do anything? Is it big enough that they need to change how their business setup works?
I'm thinking if you can't tell vodka from potatoes, you have bigger problems.
Think about self-checkout though, where
Yeah.
you're putting a bag through. What's in the bag? I don't know. So I put it on a scale and I weigh it, and right. So having some AI there that can help point out, does that bag look like potatoes or look like something else? Could be useful in that scenario.
Yeah, you'd be kind of curious, Rich, if your grocery store, everybody was buying like 20 pounds of grapes. Like that's all they ever bought.
Sounds like a college kid. It's just grapes, I swear.
Going into the implementation now, I'm in the media, Rich is in the media, and we know what it's like. We started talking about IoT years before any IoT systems were actually deployed. Where are we on that sort of deployment life cycle with Edge AI? And in addition to that, what are the big barriers right now? Like, is it a hardware problem? Is it a software problem? Is it a lack of having data science expertise, et cetera?
Yeah, I mean, I think we're just at the beginning of this AI revolution, and the world, I've never seen a world that has enough compute power. So
right.
we're going to use all the compute that's available to us. So I think that will be true for the foreseeable future. What I'd argue today is, what we're in the process of doing is trying to democratize AI, really make it easier for software developers to use AI in their applications. So we're providing tools and resources to be able to do that because this is relatively new to the industry, and it's not nearly as easy as it could be. And so that's the journey we're on at the moment. One example is we've got tools like the Openvino Toolkit where it's built for edge inference, and we make it easy. It's API-based. You can use it across a variety of silicon architectures. And the idea is you can write your application once and then deploy it on the architecture that makes sense for you. We've got model coverage of a whole bunch of different models in a model zoo, so you can use pre-trained models that we provide, or you can bring your own. But in any event, right, what we're doing with Openvino is we're on this journey of simplifying the overall workflow and democratizing AI. In addition to that, right, what we've done is we've looked at some common problems that developers face, some challenges when they're using AI, and we've got a tool called DevCloud. And what we do with DevCloud for the edge, you can take your AI application, you can very quickly go try it on a whole bunch of different types of edge silicon. We've got 400 pieces of edge hardware up there today, and we're always adding more. using Jupyter notebooks and just really easy to use interfaces, you can come in and within minutes come in and try your application on hardware of your choice and see what benchmarks make sense for you and what type of performance you're getting on those. Do you need Xeons or do you need VPUs, right? What's going to be best for you? And so we look at tools like this. We're constantly innovating to see how does the AI workflow work today? What are some of the common challenges that developers have? And then how do we go solve those through the variety of mechanisms like Openvino or DevCloud that we've been talking about?
Bill, you brought up a couple interesting points. You mentioned Xeons or VPUs, and you also said that you've never seen a world that has enough compute. Well, we definitely are looking at a whole lot of more compute and a whole lot of different types of compute with AI, just because they run more efficiently on non-traditional compute architectures. Do you think that this is sort of the death rattle of Moore's law? Do you think CPUs are not going to have much of a play in this sort of market? What's your take on the hardware aspect?
So you think about the edge, you're in a constrained environment. You may have power constraints, so I have low power. You may have thermal constraints. And so while deploying a Xeon might be your wish list there, it may not make sense for your application. Perhaps, there's a different type of XPU, we call them these days, right? A different type of compute that's going to help you with your challenge. And so that's the neat part about this era we're in, is that there is a variety of compute, and what we're trying to do is help developers understand and determine for themselves what compute mechanisms are going to be best for them. So world's going to need as much as we can generate, and our challenge is helping developers sort that out and make the right decision.
These aren't, in a lot of cases, the most economic or low cost types of platforms to deploy. If you're trying to run inferencing algorithms against streaming video, I mean, you've got to have some significant horsepower there. You've got to have a significant amount of RAM, and it's a complex system. Where does that put Intel in the mix? You don't have like a microcontroller per se that is suited for the far edge and may hit some of those sort of complex but low cost economic alternatives. Where's your general feeling that you're going to approach the market?
Yeah, our focus is on high performance compute, and we provide a variety of solutions that all offer that. So what we see is that the types of applications that we're talking about with Edge AI, they do need this high performance compute. And as more and more compute becomes software defined, we're running workloads in containers and that sort of thing, you need even more of it. And so the return is there for the businesses that are using it. We're working with a variety of customers, and some of them have been able to really come back and share data with us that, looking at, wow, when we implement, Edge AI and cameras in our robotics solutions, for example, we're able to drive cost reductions in our overall environment that, more than pay for the compute that's there. This is a similar story across the board. So, like I said, the world's never had enough compute, and the trick really is, helping developers figure out how to take advantage of that compute power that they have to implement their visions of what they're trying to solve.
What you're describing sounds like it could be handled by the programmable logic division of Intel. Is that where this would end up?
Well, the neat thing about Intel is that, there's a variety of solutions that we offer. And so, some people are going to need FPGAs to go with their CPUs. Some are going to need VPUs. What we try and do is really help the customer understand the problem, the opportunities, right? What options do they have? And then develop tools like Openvino that will work across all those computing architectures, so that the developers can build the solution. They can then select the right hardware for their solution without, regard to which particular division it comes from.
One of the things that was really interesting to me about the previous comment you made, Bill, was you're talking about virtualized workloads and high performance computing, and it brings to mind, oh, wait, if when 5G takes off, you're going to have all of these little like edge data centers. Maybe you just run on Intel hardware at an edge data center and do inferencing there. And maybe you could even do the inferencing next to the model training in a scenario like that. Is that something that's on the horizon or in your roadmap?
Yeah, if you look at compute in the future, I think what I talked here about was bringing compute close to where the data is. And sometimes that means sitting on the factory floor with that compute, because you need to be very, very close for low latency requirements and things like you might see in edge control loops, right? Other cases, you can be 100 yards away or have regional data centers. So there's a variety of ways of approaching the problem. And again, what we're trying to do is help customers figure out what solution they need for them, and then we'll help them get the right compute in there along with the right software resources for their developers. Absolutely, we're going to see evolutions here, by the way, and that's the neat thing about this industry is it never stops. We always get a chance to rethink how we're doing it and get a little bit better.
That's fantastic. Well, you mentioned Openvino. You mentioned the Dev Cloud. I know that Openvino has open source roots. I'm not as sure about the Dev Cloud, but a lot of that stuff's available online, so developers can go and start getting their hands dirty. And as you mentioned, start using AI, running AI models and algorithms on whatever architecture they choose. Is there anything else out there that our audience should be aware of? Anything coming from Intel that will really accelerate their edge AI experience?
The last thing I'll point out is we've got something called Edge Software Hub, and this helps developers take those software stacks that they're going to put their applications on top of and just make it easy to go grab one that can work for their situation. So if we think about Openvino as a tool to go and create these edge AI applications, and then DevCloud as a way to try those applications on a variety of hardware, quickly decide what makes sense to achieve the goals and metrics that the developer is trying to achieve, then the Edge Software Hub is a way to go really quickly grab a reference implementation or a software stack that you can drop your AI application on top of and have it quickly run in your environment in the real world.
And where can people find out more information about that?
So go to software.intel.com/IoT. You can find about all of this and more.
That's great. Well, I want to thank you for your time, Bill. I guess one last question is, when are we going to have these cameras everywhere, making sure that I'm not buying 50 pounds worth of grapes?
Your guess is as good as mine.
Now it's time for Tech Market Madness with Alex Harrowell, Senior Analyst at Omdia Research. So, Alex, what are the leading applications for Edge AI today in your perspective?
Well, if you look at the work we did on the Artificial Intelligence on Edge Devices report, the first thing you have to understand is the hegemony of the camera. By far the biggest subsegment is the smartphone, and in pretty much all of them, the major vendors, Apple, Samsung, Huawei, and friends, are using AI and machine learning to do various things to the images you take with the camera. They see the photography UX as hugely central to the general user experience and therefore to the value of the devices. And of course, so do downstream players like that, Facebook and Instagram, where the photos are ending up. But this centrality of photography and vision also has some harder use cases, because if you recall, deep learning and neural networks emerged in the context of machine vision, and cameras and vision play a huge role in robotics, in drones, in automotive, in a lot of industrial applications, and these are all essentially backed by deep learning neural networks in the end, to understand what's coming off the camera, and whether you're just directly analyzing it or whether you're trying to enhance in some way or what you're doing. This is causing a proliferation of edge AI in a wide range of devices. As an important subsector of this is so-called SLAM, or simultaneous localization and mapping, the technology that's used to help robots navigate their way, and robotized vehicles navigate their way around in space, and that tends to use a lot of cameras, plus other sensors like radars, but first of all cameras and therefore machine vision. So that's the first thing I'd like to point out, is that vision, photography, and cameras are absolutely critical to this, and that has a consequence that the whole thing has become very tightly bound up with the smartphone industry and the smartphone ecosystem and the supply chain. There are some relatively smaller ones like smart speakers and such, where you have some sort of AI implementation that basically handles audio and listening for wake words before it talks to the cloud. So that, I think, should give you some view into the apps. Now, just to note something about this, why these have to be at the edge of in some shape or form, you have to realize that, just to give you a toy example, Amazon Web Services Recognition, their image analysis cloud service, will charge you 10 US cents per inference. If you're doing one inference per frame on video of 24 frames a second, there are 86,400 seconds in a day. You're going to have a bill of something over $200,000 US from 1 day's coverage. Obviously, this isn't going to work for anybody. Now, in fact, at that level, you'd probably already be eligible for the kind of discount that AWS gives to customers like Netflix. But even so, obviously it's a crazy amount of money. If you took down the sampling rate by a factor of 10, that's still $20,000 a day per installation. And then you have the problem that a lot of applications just become impossible because you won't be able to detect any event that comes around faster than a quarter of a second, thanks to the Shannon-Nyquist law. So, yeah. So we've got to have your own chips, and you've got to move to the edge to do this. And then we start to look at that already puts us in a place where we're looking mostly at systems on chips, accelerators integrated in the systems on chips, and therefore like the mobile vendor, the mobile ecosystem.
As far as edge AI inferencing applications go, what processing or computing platforms are leading the charge right now?
Right now, I see sort of three forces converging on this ecosystem, converging on this space. You could say there's in from mobile with people like ARM and Qualcomm. There's out from the PC and server with Intel and NVIDIA, and there's up from the microcontroller. Now, in one of these, we're kind of taking the technology that was developed for mobile, the SoCs and the accelerators, and we're sometimes upping the power or changing the packaging to move them into these edge form factors. In the option of coming up from the PC, we're basically looking for form factors that let them deploy the sort of fairly big and powerful CPUs and discrete GPUs have done so well on the desktop and in the data center out to the edge. And I think this is where things like edge servers are likely to come in, because if you're deploying an embedded or mobile context, you obviously have constraints on power, constraints on cooling, constraints on form factor. Whereas if it's essentially a box, even if it's a ruggedized box, you don't have quite as many restrictions there, and we'll talk about some of those a bit later. Now, a key factor here really is that the mobile supply chain is absolutely huge. But you have to realize that ARM has shipped something like 6.2 billion cores. So the enormous scale of the mobile semiconductor supply chain is a real factor which has been driving this forward. So things like Mali GPU, Qualcomm's, Adreno's, and of course the NVIDIA Jetson. And the other thing we also observe here is that there's a major effort to get AI inferencing onto smaller, lighter, lower power devices, close to the scale of microcontrollers, really. And you see that with efforts to change to optimize the algorithms to work on these, to sort of up the power of that class of devices. So ARM itself has some products in that line, but we also see user companies coming into this space. So things like Google with the Edge TPU. Now, in the very long term, you have to wonder about whether we'll really be able to do this with the GPUs, as they tend to be quite demanding, quite hot chips, and whether we'll need to look at, and in fact, the scaling properties of the deep learning algorithms are not fantastic from that point of view. And we'll have to look at something more exotic forms of computation.
Can you speak to the market share a bit, and what are your projections for companies or architectures in the edge AI space?
Probably by far the most common pairing will be Qualcomm's Adreno GPUs, hexagon digital and hexagon DSPs with some kind of ARM core. That's where the scale from the mobile sector is coming from. But I'd point out about NVIDIA, even before the ARM deal, as well as their strength in in some discrete hardware for data centers and high-end PCs, they also had an interesting spike in automotive with the driver API, with the Jetson hardware. And this is interesting because automotive is a big deal. In our forecasts, it's the second biggest after the smartphone sector. Is that cars are a big deal. There's a lot of them. They're a substantial, they're a substantial sale. There's quite a lot of room in the room in the financial envelope and the bill of materials to include things. And and also, it's a context where power and space are relatively ample. Also, where there are multiple applications, so you're going to get multiple SoCs per vehicle. So we see that. So I at least see that as a potential driver of scale here, and I think, but with the NVIDIA ARM deal, if it should eventually go ahead, despite the political concerns, I find it hard to see them not being eventually the market leader here. It'll be a big fight between them and Qualcomm. What happened and what they do with the ARM Mali technology, we remain to see. They were at quite pains to emphasize they weren't going to turn it on, they weren't going to get rid of it, they were still going to support it, but how long they will do so, I don't know. Over the next 5 or so years, we expect that the SoC accelerators will be the biggest chunk of the market and probably the fastest growing, but we do, towards the end of the forecast horizon out towards 2025 though, so we expect to see a substantial ramp up of ASICs especially. Now, if we look into the companies that are going down that route, we look at Huawei in the Kirin SoC. They've done an ASIC for accelerator for AI applications. I think Apple have done one in their in-house developed chips. Google are doing so with the TPUs. That's an impressive lineup. However, on the other hand, though, if you look at the other main route at this point, down the FPGA channel, you can see we don't think we expect those will ramp up as quickly, but they will be significant. And there's some interesting names in there as well. Notably, Intel bought Altera, and they have a major franchise there. Xilinx will be there and thereabouts. Baidu, interestingly enough, have chosen that for their in-house design chips accelerator.
Thanks for listening to this edition of Embedded Insiders. For daily industry news, videos, and podcasts, visit our website, embeddedcomputing.com.